Give me a second.
Sure.
Go ahead and fire it up.
I am actually streaming.
It's running. Okay.
Yeah.
Cool.
I made sure they were not already transmitting and turned mine on. I did just get a rather vicious crash in SSMS, so I'm just going to start over and hope. It's almost like the attempt to install the database diagram destroyed the database.
Yeah.
It's almost that.
Yeah.
But even if that's the case, I can recover from that.
Yeah, I've seen that in the past couple versions. Database diagram seems to be broken.
Thank you for getting me started.
Oops. I have two of them open. Let me know when they're ready.
Okay, we got you.
All good?
Yep.
Awesome. Cool. So we all went through the exercise and had a great time. It was great working and looking at everybody's shoulder. That was kind of fun for me, at least. Hope it was for you too. This time I'm actually going to go through the exercise. So I'm going to pretend that it was given to me. You can just compare and contrast what you did. I'll talk about some of the hiccups that you may or may not have encountered. And of course we'll take questions as you have them. So I'm going to keep using the Echo database. It already had a customer table in it with the two customers, Bob and Alice. There's no need for me to recreate that, so I'm just going to leave that alone. The task was to store to-do items for customers, and so that's obviously going to be a new table. We're not going to put that on the customer table because they could have any number of to-do items on their list. We wouldn't want to have to change the database schema every time somebody wanted to add something to their list. That would be rather ridiculous. So I am going to use the designer. I will be creating the new to-do items table, and pretty much you want to get in a certain habit when you go to create a new table, whether it's with a script or with the designer. The very first thing is you probably already know what you're going to call it. We're going to call this one to-do item. Just get in the habit of always creating that first primary key. Right, you're pretty much always going to need that. It's always valuable. Let's just always put it in. So the first step is always to put that in. To-do item ID. It's kind of muscle memory, like I'm deliberately going slow now, but you guys have seen this already. I made it a primary key with the top right, which is under my picture for everybody else, but you've already seen me click it, and I'll make it identity. In fact, if you want to, you could actually go ahead and save it. If you ever, there's no rule against that. So I'm going to go ahead and create it. We have a table now that's effectively useless. It has a primary key and no data on it, but that's fine. Now, we know it's going to be a situation where customers own to-do items. We're not going to ever have a to-do item that rests in the ether by itself. It's always going to belong to a customer. Let's go ahead and add a customer ID, and we can immediately make that, whoops, I accidentally clicked primary key. I will fix that by undoing that mistake. I will go to the relationships, add that relationship. You saw me do this earlier with the, what was the other table? Phone number. It gives it a default name. In a real project, we would spend time on perfect naming, but for now, this is fine. You remember this pop-up where we have to specify which columns in both tables are participating in the relationship. Which two columns are we welding together and demanding that SQL enforce for us? Well, the foreign key, the other table would be customer, because that's who's going to be the parent. It's going to be based off of customer ID. And the child table, which is the table we're in, the to-do item, it's also going to be customer ID. In most cases, if you're following a great naming convention, it's actually this simple. You're usually just matching up the column names the same. Some projects do have a design where these can get more confusing, but hopefully you're in a well-designed database, it will pretty much be that simple every time. Where the names are obvious, customer ID, customer ID. Those two columns are the same in two different tables, very easy to understand. I can immediately save that if I want. And I'll say yes to this pop-up. It's a warning that we don't care about for presentation purposes. So now I have a table, which we can inspect. I'm going to re-remind everybody, because I still saw a few people have the problem. I want everybody to memorize that this Object Explorer, just assume it's always wrong and that you need to refresh it. Although you'll be wrong sometimes about that assumption, you'll be more often right. There were a number of times where people had something open here on the left and they thought that that was the truth of their database, and it wasn't. This data is old until you refresh it. So you're going to notice me always right-clicking and refresh. I do that all the time. It's habit now. I suggest you get in that habit, or you'll end up frustrated because you believe the schema is X when it's actually shaped like Y. So I'm going to reinforce that. Keep on refreshing. We can look and see our two columns. It's still kind of useless, right? We have a table. It's got a primary key, so we can identify the rows in it. It's a child of something, but it has no data itself. It's still actually useless. Serves no purpose. So what do we need to store for a to-do item? Pretty simple. A task name. Oops. Get the cursor right. I'm going to do a task name. This will just be something that the customer types in. And they're just going to type in whatever it is. Somebody had do laundry. It's a fine task. A priority. I'm going to do priority number. I'll pick an int. You could pick pretty much anything that makes sense. You could pick something smaller, like small int, and give them 32,000 options. I'm going to leave it int, but you could be even really more aggressively efficient. If you knew, for example, the maximum number of items any customer can have per the business rule is 100, you could even make this a tiny int, which is a byte. It would only take up 1 byte in the storage medium, the hard drive or whatever, and it would be super efficient, but it could only store up to 255. So if that limit grew from 100 to 300, the database is now unable to meet the customer's needs. So I'm going to leave it int because that's small enough not to be upset. And we need a completion date. Now, I did have it was brought to my attention, I might not have communicated this well. The completion date should be the date that it was completed. So when they check mark it done, that's what this date is. It's not a potential completion date like a goal setting mechanism. No, this is when I completed it. If I didn't communicate that well, then I apologize. But let's go ahead and put that in there. Completion date. We'll just do date and time. Maybe we'll care about what time we did it. And I'm going to leave that one null. You'll notice the other ones are not null, right? Because it doesn't really make sense for a customer to have a task that they don't have a name for it. I mean, what would the task be if it were blank? What do I need to do? I don't know. It's a blank item. We're just going to assert that they have to give it a priority number. We need a number in there, so we're going to demand it. But if it's not complete, we don't necessarily have a date. Now, some people might actually have, and I saw some people do this, you might have another column that is a bit column for is completed. There's nothing really wrong with that. Depending on what team you're on, some teams prefer a flag and a non-nullable date. Some prefer a date that is nullable. I've opted for the nullable option. But if you did the flag way and it worked, nothing's wrong. You haven't really broken any rules. But depending on what team you're on, you might get different direction from the tech lead. So be ready for that. But I'm going to use a nullable date because that gets the job done. Now I have no records in here, so I can add these columns and it won't complain about nullability. You'll notice on the left, I just saved the table and it's this part on the left is wrong, right? We got to refresh it. Don't forget to keep refreshing. Now it's the truth. Now it's correct. Keep refreshing it forever. Okay, so we got customer. So that's what I'm going to tell you is probably the table you should have designed, or something close to it. If you used a flag, there's nothing wrong with that either. So if you got a table design that's pretty close to that, the names are approximately the same, the data types are close, then you've done good as far as the data table. I do need to go ahead and put some data in, so some of my examples will mean something. So this will be a bit of a boring part, but bear with me while I put in a few items. And I'm only going to put in a few, just enough to sort of show off some SQL stuff. I will actually make a note here. You'll notice I named the actual column priority number. That's because I just happen to know that the word priority is a keyword in T-SQL. You will run into this pretty often. You can sometimes reuse keywords in the language, but you're forced to use the brackets just like you're forced to use it with spaces. It might behoove you one day when you have a little extra time, you want to curl up next to the fire with some great reading material, quickly scan some of the reserved words. You can Google the reserved words for T-SQL, and you'll see what words you should probably stay away from. Words like user are already used in some way. Obviously, we've seen things like get date, so you probably don't want to column name get date. Just because it's confusing, it'll be weirdly colored. So let's try to avoid those reserved words.
And it turning blue there is a hint, right? That's
Yes.
one of those words.
Oh, absolutely. Yeah, Harper's making a good point. I will sometimes, if I'm not sure, I'll type that. I'll be like, I think use is a reserved word. Yep, it is. I think update is a reserved word. Well, clearly that's the update statement. Is group a reserved word? Yes, it is. Is by a reserved word? Yes, even if it stands alone as a reserved word. I generally try to avoid those. That's why you might not have noticed, but I deliberately called my column priority number because I just happen to know that that one was not already taken. So continuing on, I got a priority number. Oh, and completion date. I don't even need to put that in there, right? Because it's going to be nullable. Let me do this on a new line. So, buy food. All right, I'm used to C#. I accidentally hit a double quote. That needs to be single. Priority number 1. Food is important. Oops. What did I forget? Customer ID, that's correct. And I generally did forget it. That's a mistake. But easy enough to resolve. So we're going to give Bob a buy food. We'll give him another... I'll steal the other gentleman's ID. I'll do laundry. That's enough for him. We'll jump over to Alice, change to number 2. And all these things are sort of happening. They would be happening by the customer by some other queries. But I'm just jamming these in real quick so we can get to the query writing, which is the fun part. She wants to buy a car. That's her top priority in life. So we're going to give her that. We'll walk the dog. Unfortunately, the dog comes in second. All right. So we'll take a glance at our data set just so we all are not lost as to what it exists. This is the rough state of our system. So what do we have? Bob has 2 items, Alice has 2 items, none of them are complete, and their priorities are 1 and 2. So let me look at my list at what I asked you to do. List all incomplete items for a given customer ID ordered by priority ascending. Alright. So I like to usually start off with select star. I don't put that in production, but I start off with it. All the items. To do item. I'll just call that T. My style is, if I can, I'll go ahead and put a where clause on. I'm just trained because of the missing where clause thing with update and deletes. I often personally put on the where clauses pretty soon. So if we do that, that would be Bob. And then order by priority ascending. Now you might look at that record set and say that it's already ordered ascending, meaning priority 1 is the first record. One thing I want to warn you about is ordering is not deterministic. That's a big fancy word for it might be different next time you call it. If you really need something to be ordered in T-SQL, don't depend on the fact that it looks ordered when you do this manually. Definitely give it an order by clause that will force it to be ordered. There's some magic under the hood that can cause some queries to be ordered a certain way for years, and then spontaneously that exact same query on the exact same data set comes in a different order.
Yep.
And the only way you can guarantee that order is order by. You hear some yeps coming because that one's hard to track. That one can get you. You just don't depend on it.
It's a threshold of a certain number of rows.
That's
the
right.
Engine under the covers takes a different path.
Yep. It decides to do something really efficient because, as far as it knows, you don't have a special priority, a special order by that you need. So I recommend you always put that in there. I didn't put an alias on here, so I'll do that just to make it nice and complete. Now it's correct. So the first thing I wanted, once again, list all incomplete items, task name and priority for a given customer ID. Let's shrink this down. It's got too many columns coming back. T dot task name, T dot priority. Because this is probably all that the application code actually needs to show on the user interface for the customer. Oh, did I do this correctly? I did not do this correctly, did I? What did I miss? Was incomplete, that's right. I'm actually showing every single thing regardless of completeness. So list all incomplete items for a given customer ID. So let's improve this by adding an and. Completion date is null. Now it looks the same, but it's actually working correctly now. I'm going to once again bring your attention. When I walked around the room, I saw a few people that did equals. Remember that equals doesn't work as you expect. Whatever your gut tells you, whatever your intuition tells you, unfortunately is not the case. Nulls are very special. You'll notice when I said equal to null, which should mean the same thing as is null, produced a different record set. It produced an empty record set and would actually always produce an empty record set. You can't use the equal operator as null. You got to use the is operator, and then it begins to function correctly.
One of the rare cases where it won't give you an error too. It just
Yes.
does the wrong thing.
Yeah, that's one of the scariest bugs in the world, where it doesn't throw an exception or an error in your face. Sometimes we as developers get annoyed at, we're typing something, we're trying to get something to work, and it keeps on showing red. I assure you, red is not the worst thing you can see. The worst thing you can see is no red, no complaints, and it's just wrong. That's the worst case to be in, because then you don't know you're wrong. At least with an error, it's hitting you in the face and you won't accidentally give that to customers and mess up their world. So the first task is pretty much covered there. List all incomplete, right, for a single customer. Give the task name and priority number and order by the priority number ascending. If, just for fun, if we needed a descending, we can reverse that with DESC, and if you watch, do laundry will pop to the top. Now it's big number to small. So ascending just means small to big, descending that. You'll be ordering by numbers and dates a lot, so be ready for that you can order both directions. Any questions on that particular query?
So so more than two different columns can have the same alias? Because completion task name and priority number have the same.
Gotcha. He's asking a question about the aliases and how often I'm using them. The key thing to remember here is this alias T. Let me get the red squiggles off the screen, because they're making it look like I'm not typing well. And I think I am doing a pretty good job. There we go. I'm only aliasing that table. Right, so that T comes from that particular table.
Okay.
I can use that T often all over the place to reference that table. So in this case, each of these columns came from that same table, so I'm doing T dot.
Okay.
I'm also making, in the where clause, both predicates are T dot something. And even in the order by I'm using it. So I'm actually using that alias all over the place. I didn't have to. I could have left this T off, removed all T dots, and this script would still work.
Okay.
What you're going to find, though, especially as our days move forward and you start working on bigger, more awesome projects, your queries will become big and fancy enough that the aliases will be really fun. In this case, it was a little overkill, but you're going to want to use them a lot. Question in the back?
So we know priority number is an integer.
Yes.
If it was like a string or something, would you still use descend and ascend as the argument of order by? So like if it was like if you were trying to order alphabetically or something,
Yep.
or reverse alphabetically, would you still use ascend and descend?
Yep. So the question is about ordering by ascending and descending on strings. Yes, they can be ordered both directions, and I'm going to tread lightly here, but yes, they'll probably be ordered pretty much what you expect alphabetical, but I'm putting a big asterisk on there. There are some special cases. You want to be careful there. Yes, my message is yes, it can order strings, and it will do it deterministically, but there are some special, strings are always a little trippy. You might get results you weren't expecting. So yes, but pay attention, do some testing. Make sure it's what you expect. But yeah, there's no limitation there. I think even things like Booleans, which are bits, I think they can even be ordered. And because they are basically zeros and ones, you get all the falses first.
And same with dates?
Yes,
Okay.
you can absolutely order by dates. That's absolutely true. It's a good question. Any other questions about this particular script? All right, let's go on to the next thing I gave you. The next one was mark a single item completed. All right. Oh, let me make one more comment. Let me back up to the previous script we were just looking at. And I want to point out that I put in the where clause, t.customer ID. I filtered on a column that's a primary key elsewhere, but only a foreign key here. You've only seen us really talk about using where customer ID equals 1 on the customer table, but you're not constrained to that. You might have thought that I needed to join here, but I didn't. Or you might have thought in order to filter on customer ID, I have to join the customer table because that's where its primary key is. But because of that foreign key relationship, the values for customer ID are already in the to-do items table, so I didn't need that extra join. You might have in your script put it in there, but you can see I didn't even need it. All the data I needed was in one table, so I didn't even need a join. Just wanted to comment that that was optional. If you did join, you haven't broken anything, but it might just run slightly slower than necessary. Okay, let's do the marking one. So mark a single item completed. Well, clearly, and I'm going to start with the select. Remember what I told you about where clauses? I've programmed my own brain to always type a select statement first, and then we'll translate it. So it's an item, so it's a to-do item. So we're definitely going to need, at a bare minimum, that table. A single item. So of course it makes you ask the question, what is the developer going to be sending me? He could send me a lot of stuff. But if you're the DBA, I suggest you actually make a demand. And the demand should be, send me the primary key. You might be tempted to do a where clause that is the combination of lots of these values. That temptation is risky. You probably will end up on projects where certain rows, those column sets are not unique to a single record. You think that they should be, but they might not be. A single customer might have a seemingly nearly identical row in the child table, in this case the do item, and you might think I can just have a really complex where clause. I want you to hold a little discipline in and say, no, we need to have the to-do item. And if your teammate, or if your teammate is you, because you're writing the app code, if the answer is we don't have a to-do item ID available, then you should earlier in the workflow acquire that ID and have it available for the delete process. Just be really careful with thinking that it's a good idea to delete without a primary key. Try to aim for doing all your operations, select, update, and deletes, hopefully on primary keys, most of the time, and inside the app. So we're going to assume that we did do that correctly. So the act of marking one item completed means we do have a to-do item ID. So let's go ahead and put in the predicate. To-do item ID. We'll do number 4. We'll do one of Alice's. We can do a select. That looks correct to me. That's Alice's record. And then we finally turn this thing into an actual delete. So I will run this. I'll get 1 row's affected. And I'll just quickly reselect all of them to prove that we are down to 3 rows. Alice is down to only 1 thing to do. I'm sorry, I just deleted that. I did that wrong, didn't I? My goodness, nobody caught me. The point was to mark it correct. I just destroyed it. That was overkill. So I did that wrong. Even with the correct where clause, I did it wrong. Let's do that correctly. I apologize. I will do the same thing to one of Bob's records. We'll do number 3. And I apologize. Here I typed delete. I needed to type update, right? I need to update completion date. I'm going to pretend that we're UTC on our team. Now it's been marked complete, and if we look at the record set, we should be good. I apologize that I deleted that first record. That was the wrong thing to do. This is good. All right. So now, if I still have that old query open, we only get by food. So although Bob, so it's customer ID 1, Bob does have both of them. Only one of them has been completed. The other one is not. That previous query, which is list all incomplete items for a given customer ID, and we are filtering on Bob, completion date is null, is only going to pick by food. Right? And it's only picking by food because by food is the only row that has a null completion date for that customer. So now we have these queries working together. We have one that's selecting based on completion and one that's marking things complete. I've deleted that update statement, but it was in this window a moment ago.
It's okay, Alice just gave up on buying that car.
She did give up. Yeah, we just destroyed it, right? We just knew that it was so impossible for her to complete that. We took it upon ourselves to destroy her data. No, that was a mistake on my part. I apologize. I like that. I like that answer, though. That was a pretty grandiose goal for her to have, compared to the paltry sort of a small tasks that are on these other records. So that is that update statement. If you did something close to that, you're golden. Make sure you definitely had some sort of where clause, so you didn't mark everybody complete. And it doesn't matter if you use date versus UTC date. Different teams will want different kinds of dates stored. I have a preference for UTC whenever I can. When you program for UTC, your software is much easier to be elsewhere. You can take it to the West Coast and it's still correct. All right. Create a report of all customers that have at least one incomplete item. So this particular task I forgot to mention earlier this morning, way earlier this morning, a particular keyword that I should have mentioned. So this one was probably tough for you to complete. That's okay, we'll still go over it. You probably still got pretty close. All customers that have at least one incomplete item. Let's start with customers since that's what it starts with. Probably going to need to do a join, right? Because we were just now talking about joins. Remember that by default it's an inner join, so I, as a style, don't type the word inner, but you could have. If you did, that would be fine. On. It's always going to be, for our product that we're doing, the same columns. Right, so there's all of our relationships. Delete. Create all customers have at least one incomplete item. Completion date is null. Remember, I can't do equals there. I got to do is null. And I can pull out customer ID. Now, because I accidentally, I'm gonna change the date a little bit just to make this better. I'm gonna nullify everybody. So I'm gonna make all of the values incomplete, and I'll show you why. Kill that. So many of you got to this step, and if you got this far, pat yourself on the back, you get an A+. You did this query correctly. What I forgot to tell you, if you look at this data set, it's kind of got a problem in it. It's correct. It does meet the criteria. Report of all customers have at least one incomplete item. It is correct, but what's the problem? Doubles. You got duplicates. The first two rows are identical, and so they're in the way. The keyword I forgot to mention earlier today in the very beginning is the word distinct. If I could type it correctly. Distinct does exactly what it sounds like. It'll give you just a distinct set. This will drop from 3 rows to 2. This is what I really wanted, but if you had 3 rows, you still did it pretty well. All right, so we end up with a row. This is not, by the way, the only way to do this particular query. There are many other ways. Some of them require joins that I haven't talked about yet. We'll be talking about those tomorrow. This is simply one way to do them, but there's many ways to get this done. In fact, you'll often find if you become true full-scale DBA that there are lots of ways to get work done, and depending on the scenario, certain ways are actually more efficient than others. For our small data set, this gets the job done and lets us practice using a join. The last one, delete all items completed over a week ago for a given customer ID. This will be our last one for this exercise. So we're going to be talking about to-do items. Let's go ahead and get that in there. It's for a given customer ID, so we know what we're going to do. We'll go ahead and just pick Bob. There are his 2 items. Over a week ago. In order to make this mean something, I'm going to give I need to come up with a scenario. I need to give one of his records an old date. Is what I basically need to do. pardon me a moment while I set up the data to make the query act reasonably. We will do number 3. To do item equals 3. That's the one. I'll convert this to an update. T set completion date equal to, and I'm going to give it just a nice old date. I won't be using the one that Ali recommended, because I'm just going to do a quick and dirty. So now we can see the date. So he has 2 items on his list total. One of them was completed 17 and a half years ago approximately. So that's definitely older than a week. So delete all items completed over a week ago. Now you're seeing me put 2 ands in here. It's my personal style. I don't know if it's correct, if it's necessary. Ali might be able to chime in on that one. I'm going to demand that the completion date is not null, and also could do a comparison on it. Completion date is less than, and this is the part I didn't show. If I remember correctly, you can actually do integer math, and that gets you a week ago. If you're ever not sure, open up a new window, do a select on that value. You can do a select without a table. You can actually just select a word, ASDF, and you'll get a record set with ASDF in it, which means you can sort of test out if this is going to work correctly. This should end up June 7th. June 7th, exactly 1 week ago. So integer math on get date is days. I don't know if that's a great way to do that. Ali probably would have a comment on that. He's probably used it more than I have. But this gets the job done. You can see if I press F5, we are getting that one. That one is really old and is currently not null, which means now we can actually do the delete. T. We'll get 1 row affected. And if we reselect out all of the rows, 2, I don't know why I hit enter there. There we go. It did actually successfully delete. So one of the things I did not show you was that. So if you got the top of this correct and you were struggling here, you still get an A+, because I had not shown that yet. However, if you had Googled, T-SQL space subtract days, or get date subtract days, or some keyword set, I'd be willing to bet one of the first hits would probably be Stack Overflow, and it's probably this answer, something of this nature. They would have told you something like this that got the same job done. So if I were given that exercise, that's how I would pretty much do the work. You'll notice I have a tactic here. I don't just write the query and hope it's correct. I like to generate a data set, or go in there and tweak the data, and then run it and make sure that I got the filters right. Like, I could have written this without setting a date of 2001 on that one task for Bob, but you don't really know if you've written it correctly till you test it. So I deliberately set that up and tested it. Any questions on that particular exercise, or any of my answers to it? Anything from Winston-Salem? I've covered a lot, so if there's any questions in there or comments from Ali, just let me know. Gotcha. Okay. So the last thing I'm going to talk about today, I think that we do have time, so I'm going to cover the minis. Okay. We have a lot of things open. I'm going to close all of them, and I'd like you to follow along. Let's go back into follow along mode. You're welcome to use the same database if you want. As long as you have a customer table, you're set. As long as it's got anything in it. A couple columns and a couple values, a couple rows, and you will be set. So we've talked about you can relate data in a relational database. Primary keys to their associated columns are effectively one-to-one. We've obviously talked about one-to-minis, right? We had the to-do items and the phone numbers. That's where we had one owner record can own lots of child records. That relationship is enforced by SQL if you set up the relationships correctly, and then relationships pop up, and children point to their parents. Well, everything we've shown so far, and we'll look at that, the phone number, had one customer ID, so it had one parent. Same thing with the do item. It had one parent. Well, you can do something kind of special in SQL. You can create a many-to-many relationship. And you do that by having two parents and some table in the middle with two foreign keys, one going each way. An example of what we're going to talk about now, we already have a customer table, so we know what a customer is. We're going to create a products table. That product table is just going to live on its own. We'll throw a couple products in there, some widgets, phones, tables, tablets, whatever. And then we're going to show you how to do favorites. Because if you think about it, a customer cannot own a product. That is to say, they can't own that record. They might be able to purchase it, but they can't own that record. And a product can't own a customer. Obviously, inanimate objects don't own people, hopefully. But it does make sense that a single customer could favorite many products, and a product could be favorited by many customers. That results in a need for a many-to-many relationship, where there's really no single owner. Both sides can have as many of the other side as possible. And we do that by creating a table in the middle. It's often called a lookup table. I've heard it called mini tables before. What do you call it?
Cross-reference table.
Cross-reference table. They're all pretty much synonyms to me. They all mean the same thing. That's what we're going to do now. So follow along, same database. We're going to create a new table. We don't need to put much in here. It's going to be a product table, so put a product ID on it. Do the same thing we've been doing, make that primary key. Pull this up, make it an identity specification. Double click it correctly, there we go. And I'm actually just going to put product name on it. For this demonstration, that's all we need, is actually just one string so we can differentiate it with our eyes from all the other products. I'll save the table and call it product. Now I am moving pretty fast, but I'm not doing anything new here yet. Right? I've created a table in the designer like I always have. I got in a primary key, I've made an identity, and I put on a string so we can understand what we're dealing with. I'm going to go ahead and put in a couple products. Let's do a new line there. We'll do a car. What else are we going to do? We're going to do a laptop. And I'll throw in a camera. There we go. Now I know I'm moving pretty fast, but I'm still not doing anything new here. We've been doing this a few times today. So if we review what the product table looks like, we got 3 products in there. Number 1, 2, and 3. Just to remind you, don't forget we do have customers in there as well. Customers. Alright. We can view them both at once if we want. So we want the ability for Bob to be able to mark as his favorite whatever products he wants, and we want any product to have as many customers favorited as we can, as we want. This is where a many-to-many comes in. But a many-to-many is not like a natural relationship. When we opened that relationship, it was just effectively a one. You can build one-to-ones with it or one-to-minis, but you can't build many-to-minis. So we're going to do that with a middle table. We're going to name that table for its purpose. I know I'm moving quickly. If I need to slow down, just raise your hand. But so far, I haven't done anything new. Still haven't done anything new that you haven't done yet. I'm going to create another table. This table is going to record the favoriting feature. It's going to have all the data for favoriting as a feature of our software. I'm going to call it favorite ID. You know what I'm going to do, don't you? Make it a primary key and identity 11. You can start to feel that for people like Harper, Ali, and I, we've done this either with scripts or the designer thousands of times. It becomes very repetitive, but that's good. You get used to it. Becomes a bit of muscle memory, and you're good. So in order for this to become a many-to-many, we need to do what we've already done, both with phone number and with to-do items, but we're going to do it twice. We're going to have a foreign key to both tables. Right? This is going to be a lookup or a cross-reference table for both. So pretty straightforward. You've already done this before. Let's throw a customer ID field on there. We can do a relationship. Doing this the same way you did it for the previous exercise. I haven't changed anything. We're not doing anything new. Still going to pick the customer table as the foreign key because this lookup is a child of customer, but it's also going to be a child of product. It has 2 parents. Favorite customer ID, customer ID. That looks correct to me. Close. So we got one side done. That's just like the phone numbers and the to-do items. But we're also going to put product ID. Same spiel. We got the new column. We got the same data type. We open up relations. We had a second relationship. We open this up, we follow the same pattern, but this time instead of choosing customer, it's got to be the product. All right, we're going to do product ID. That's the primary key in the other table. And in our current table, we make sure that that's also product ID. Once again, we're just making the two drop-downs match. All right, you pick the other table and make the two drop-downs match. Save this. Now, this table has no rows in it, but it is now capable of storing information regarding favorites. Okay. You'll notice the tables list is old. It's missing our table. I can hit refresh, and there it goes. Now, it's unfortunately possible with this data, the way I've got it set up, to favorite the same thing twice. And that's going to be a problem. And I will come back to that in just a moment. But I want you to remember that we've built it correctly, and we're going to shove some data into it. But there is a problem with it, and we will need to fix that problem. And if all goes well, we will fix it before 5:30. I'm going to close out some of these windows that I don't need. I'm going to keep these two open. So remember that that's our data in the outer tables. If we look at the favorites table, it's empty, as you would expect. We have never inserted data into it, so it's empty. So the way that we are going to associate things, we're going to mimic what a customer might do. Let's say Bob favorites the car. That's his favorite car. How do we do that? We're going to insert a record. That's all we're doing. We're not actually using any new skills. You're just using a composite sort of version of what you did in the previous exercise. We're just going to insert into this table. Insert into favorites. Yeah. Customer ID and product ID. Those are the two things. Remember, it's a 3-column table. Let me expand it so you haven't forgotten what it looks like. And you can actually see it's only composed of keys, either its own primary key or 2 foreign keys. So we'll insert into it the values. Bob happens to be number 1. Car is also number 1 in the car table. We can insert this row, and it's in our favorites table. Now that's not very human readable, right? It's 1, 1, 1. But those are 3 different kinds of 1. The first one is the ID of the favorite row itself. 1 is Bob, and that 1 is car. And we confirm that here. And I'm going to show, let me show you the one problem. So we've inserted that row. We can insert it again. I'm actually not going to press F5. I just want you to know that I could press F5 and it would work. It would work because there's no rule that prevents duplicate records there. But if you think about it, that's kind of a bad thing, right? Why does Bob get to favorite it twice? That's really kind of a nonsensical thing for him to do. But even as a customer, he's allowed to do nonsensical things. But we as DBAs kind of want to prevent ridiculous data sets like that. He could favorite it 1,000 times, but what does that even mean? It's the same car. He's the same person. That doesn't really make sense. So what we're going to do is we're going to actually, we can actually use indexes here in a special way. Now, if you're following along, remember, as we established earlier, that index creation this way is not functional on many people's systems. So just watch. That's perfectly fine if you're just watching this part. I can build a new non-clustered index. I just want to show you this is possible because I want to show you an alternate usage of indexes other than just the lookup performance that I mentioned earlier with that email example. I can add the 2 columns. I just picked 2 of them, and there's a little checkbox here that says unique. And if I check that, it's going to build an index, but in addition to building an index, for the same reasons I discussed earlier, it'll have an extra feature set, and that is you can never have the same customer favorite the same product twice. You can have 0, you can have 1, but you can't have 2 duplicate records. Doing this, you see I have this new non-clustered index with a terrible name, means that if I tried to insert a duplicate record now I will press F5. It doesn't work. And if I ask for the reason, blah blah blah, unique index, big name, duplicate value is 1, 1. It won't let me do the duplicates. You will see people do this often, so I wanted to show you it's possible. Not really super critical for what we're talking about right now. Just understand that you can enforce uniqueness across multiple columns for any table of your choosing using unique indexes. It's a cool feature and allows you as the DBA to really bolt down the integrity of your data. Right? I don't know if you've heard yet, there's a phrase developers use, garbage in, garbage out, GIGO. We talk about if you let in a whole lot of bad data to a database, you generally get bad data back out. The reports are wrong, or they're corrupt in some way, or they're sort of messed up. One of the ways good DBAs try to prevent that is they'll use techniques like this. If the performance impact is worth it, they'll use techniques like this to make sure that we don't have ridiculous data combinations. It doesn't make sense to favor it twice, so let's prevent it altogether. And this is prevented at the database layer, so even if the application person allows it on the UI, it still doesn't happen, and that's good. So we can really lock down the product. Okay, so there's a refresh of the 3 data sets, and I will do I actually was going to transition to exercise, so what I'm going to do is just pick one of the queries that I would have given you and show it to you, and that'll be the teaser for tomorrow morning. So, list all favorites for a given customer ID. So we know we're going to need the favorite table. Let's go ahead and get that in there. The customer ID is always already on the favorite table. Well, that's great. We can use it as is, where f.customer_id equals 1. And that's going to be the record for Bob. List all favorite products for a given customer ID. So now we actually want the product. Let's do a join and bring the product table in. You can just watch here if you want, because this is going to be the last thing I show. Product ID. I'm so used to typing the other. P.product ID. So now we have all the data, lots of ones on the screen, but now we change the select to be much more concise and only bring back what we want. P.product name. I got rid of squigglies once again because it's all latent. So of the things I would have given you an exercise on, list all favorite products for a given customer ID. For Bob, that's his one favorite. He only favorited the car. And if we change to Alice, we'll just get an empty record set because that join, the intersection, the Venn diagram would have no records in the middle. So that's Alice's. Alice has not favorited anything, so there are no products to show. I'll put it back to Bob. I'll give him one more favorite. Just for the fun of it, I will give him the camera. Alright, so that's now the favorites table is now 2 records for Bob, still none for poor Alice. But if I rerun that script, he has favorited car and camera. And that's one of many things we could do with that. We'll resume that tomorrow, and we'll start off with a fun, quick follow-up to this exercise. But I think that's good.
Could you pull the customer name in that too?
Absolutely, I can pull the customer name. So the question is, can I pull the customer name in? The answer is yes. We have multiple ways to do this. I'll pick the quick and easy way to show now. Let me see here. We're given customer ID.
I was asking, could we search by Bob's name instead of a customer ID? Like, what if we only knew the name?
Okay. Gotcha. I'm gonna type this and then I'm gonna talk. I'm gonna do customer ID and customer name. I'm just gonna do first name. That'd be good enough. So yes, I'm able to pull back the customer information, and what I've done is add another join. This is actually a pretty good question, right? Because so far you've seen joins, but you've only seen one at a time. But the real message here is there's no limit. So I was able to bring in all 3 tables that are involved in our product here. All 3 tables are at work. I brought in the customer so I could re-deliver out to the UI, if I wanted to, Bob's name. Now because the spec for this need is to list all of the favorites, he's on there multiple times. Sometimes that's what you want to do. It's also possible, I guess I'll show multiple record sets. You think that's fine?
What was that?
Multiple record sets?
He was just saying, can we search by Bob's name? Like, we didn't know the ID, if we didn't know the customer ID there. Like, would
Sure.
it be- yeah.
Well, now that we've brought the customer table in, we can do anything with it that we want. So we can say where first name equals Bob. We get the same record set, and if we change it to Alice, she has nothing favorited. Alright, so I'll put it back on Bob, and you can see what we get back. Now Bob is repeated. There are ways to get around that. We could do multiple record sets. We could bring Bob back as one row. I think it's a little bit out of scope considering our time. This might be okay though. If your spec is bringing us back, we don't mind if Bob is brought back on multiple rows. This gets the job done. And it's still pretty efficient. We're not doing any loops here. We're not doing any cursors. We're using set-based stuff. We're using standard SQL. And this would run pretty fast. Now that we have changed the where clause from customer ID to first name, it's very likely this will slow down if the record sets were large, because we were originally seeking to the customer, and SQL can use some optimizations to make that efficient. But since we changed first name to Bob and we do not have an index on Bob, or excuse me, an index on first name, this would basically have to scan that whole table. So this one does not perform as well as the customer ID seek, but for our small data set, we don't care. Any other questions from Winston-Salem?
Yeah, we got one kind of coming in. Yeah.
Okay.
Yeah.
Any in Richmond while we're waiting for it to be typed? All right, we'll wait on the Winston-Salem question.
I'm saying, can you paste your 3-table favorite search that you got right there into the code channel? In Slack. We'll do it in a minute. Yeah.
This laptop is not on the Empower Slack at the moment.
Okay.
So
I'll get
not
you-
conveniently, but we'll get that to
I'll
somebody.
get you on there. Yeah.
Yeah. We're going to pick up tomorrow pretty much where I'm leaving off, because I do want everyone to do a small exercise regarding this new favorite table and get comfortable with the many-to-many aspect, which means I'll have to type this again anyway, and we'll see it tomorrow morning, if that's good enough.
So in this case, the favorite is the parent?
The favorite is a child of two parents. That is to say, customer has no foreign keys, product has no foreign keys, favorite has two. It points at two of its
Does that have
parents.
more?
Excuse me?
Does that have more?
Yes. And in fact, in advanced scenarios, if you hear people who do very large sort of business intelligence apps and they have a lot of data stored in SQL, they talk about fact tables and dimension tables. A fact table is primarily a table that's almost entirely composed of many foreign keys, sometimes dozens, scores of them. You could have 50, and then a couple other columns that talk about the fact of the intersection of those dimensions. So you can think of it as, well, I'll just leave that to another day.
Like, makes searching easier, I guess.
Yes, when you already know, especially when you know a lot of the values of the dimension and you know you're going to be querying often and you need to get aggregates of the facts, that's why we have those facts tables and dimension tables. But a fact table is a fancy term in SQL for, it's like this favorite table, but with dozens of foreign keys and a few other columns. Tomorrow I'm going to add some columns here to make this favorite table look a little bit more impressive. Yep.
Thank you.
Thank you. Thank you for coming. Harper, we done with the stream?
Yeah.